Hello viewers, welcome to my channel KK Concepts of Electrical Engineering.
Traverse electromagnetic wave TEM. A uniform plane wave is a traverse wave. Let us consider a wave which propagates in the positive direction of x axis. For any wave traveling in the x direction, the yz components of the field are zero since the field is a function of x and t only. Now the consider a propagation equation that del square E equals to dou square E by dou x square equals to mu epsilon dou square E by dou t square. Now let Ex, Ey and Ez be the components of E along x, y, z directions. Then dou square Ex divided by dou x square is equals to mu epsilon dou square Ex divided by dou t square. Similarly, dou square Ey by dou x square equals to mu epsilon dou square Ey by dou t square and dou square Ez by dou x square equals to mu epsilon dou square Ez by dou t square. Now we know that del dot E equals to del dot D divided by epsilon. Then this can be written as 1 by epsilon into del dot D, and the magnitude of D is nothing but rho. From the assumptions made while deriving the wave equation, the charge density is equals to 0. Then the above equation del dot E equals to 0. Now we have that del dot E equals to dou Ex by dou x plus dou Ey by dou y plus dou Ez by dou z. This is by the definition of divergence. Then this equals to 0. Now we have assumed the wave is independent of y and z and is the function of x and t only. And the second term and third term will be equals to 0. Then from this equation dou Ex by dou x equals to 0. Now differentiating with respect to x, we'll get dou square Ex divided by dou x square equals to 0. Now from these two equations, we can write mu epsilon dou square Ex by dou t square equals to 0, where mu is not equals to 0 and epsilon is not equals to 0. Then the term dou square Ex by dou t square equals to 0. Now this is a partial differential equation and the several possible solutions are there, that Ex equals to 0 and Ex equals to A and Ex equals to Bx plus C. These are the possible solutions for this equation, in which these two solutions are not representing the wave. So Ex equals to 0 is considered as a solution for above equation. A wave traveling in x direction does not have component of field E in the direction of propagation. Now this can also proved for magnetic field, that h of x is equals to 0. This proves that the wave is transfer wave and has the components of E and H in y and z directions only, which are normal to the direction of propagation of wave. Hence, the electric field vector E and the magnetic field vector H lies in the plane which is at right angles to the direction of propagation of the wave. The uniform plane wave is referred as traverse electromagnetic wave, that is TEM. If the direction of wave propagation is along x axis or x direction with respect to time, then along the y, electric field will be Ey, and along z, magnetic field Ez will be there. If the propagating wave is coming towards us, the magnetic field vector H is coming from our right to left, and electric field vector E is coming from bottom to top. This is the plot belongs to E5 in plane parallel to the x-axis and xy plane. Instantaneous value of EY are along OY. Similarly, this is the plot of HZ in a plane parallel to x-axis and xz plane. Instantaneous value of Hz is along the z-axis. Then we have dou square Ey by dou x square equals to mu epsilon dou square Ey by dou t square dou square Hz by dou x square equals to mu epsilon dou square Hz by dou t square. Now, when you modify these equations like dou square Ey by dou t square is equals to 1 by mu epsilon dou square Ey by dou x square for this, and for this dou square Hz by dou t square equals to 1 by mu epsilon dou square Hz by dou x square. When you consider the scalar magnitudes of Ey as well as Hz. In the next videos, we need to find out the solution for these equations.
If you have any suggestions and queries, please mention in the comments. If you like this video, please like, share and subscribe. Thank you for watching the video. Please stay tuned for more videos.